Hi there, this is a IQE video by John Murphy. Oh, sorry about the Discord notification. Um, this is going to be about the Bernoulli equation, and I'm going to go ahead and start off with the calculation. So the calculation question is going to be about a kid who just got a new toy for Christmas. He ended up getting the new water blaster, which launches water given a certain pressure is applied to the pressure plate on top, kind of like a stomper, kind of like how you can kind of think about a rocket getting launched whenever you stomp on it with air. But instead this launches water according to his jump. If the kid applies his 4 ATM pressure to the pressure plate with atmospheric pressure to the out tube, how high will the water go if the area of the pressure plate is 0.5 meters squared and the tube area is 0.1 meters squared? The volumetric flow rate is going to be 0.5 meters cubed per second, and the initial height of the pressure plate is 0.3 meters tall. How high will the water be launched? So we're going to go ahead and assume steady state and incompressible. All jumping weight is on the pressure, basically just like everything is going down on that pressure plate, and we're going to go ahead and kind of break it down by a system through that. And water is launched perfectly vertical, it's adiabatic, and volumetric flow is equal to going both down and up. We're going to be looking for the height, which is going to be equal to Z2. And the properties that we're looking at is going to be density of water, which is going to be 1,000 kilograms per meter cubed, and gravity, which is going to be 9.81 meters per second squared. The known is going to be going ahead and describing it with a picture. My art skills are bar none. Or, I don't know how the expression goes, but that's going to be my picture right there, and we can go ahead and go down to the solution. So we're going to go ahead and start with the Bernoulli's equation, and we're going to notice quickly that we need to find velocity of 1 and 2. This can be done by dividing the volumetric flow rate by the area, which are everything's given there. So we get V1 to be equal to 1 meter per second and V2 to 5 meter per second. We can then solve for Z2, which with some unit conversions, we go ahead and get 40.39 meters high, because I can't visually conceptualize numbers when I'm making these questions. So it goes up half a football field, basically. And so going down to the conceptual question, this is going to be basically asking, if we have a tube and it has constant volumetric flow rate, is the fluid going to be faster in the smaller areas or the larger areas? I feel like this is a pretty important question to ask a lot of the time when going and approaching Bernoulli equations. And I mean, the answer is going to be obviously that the smaller areas are going to be a faster velocity, just given that the volumetric flow rate divided by the area is the velocity. So the lower the velocity means you're dividing by a smaller number, which means that, the lower the area, the higher the velocity. Yeah, so if the area is going to be lower, then the velocity will be higher. Thank you for watching this video, and stay tuned for next week's edition.